Hello, everyone, and welcome to the fourth and the final part of the series Order Based Planning with Flexible Master Data. Before I start with this, my sincere apologies to many of those viewers and subscribers who have been messaging and texting me as there has been a delay in publishing this final part. So, I was primarily pretty much occupied with my project activities, and hence this delay in releasing the fourth part. Now, to start off, in this final part of the video, we will go through deployment planning and TLB planning as a part of the functionality in order-based planning. In my previous videos, we have seen how to set up the required master data, how to set up the required profiles, and based on that profiles, how to update the master data, take multiple runs, be it in heuristics or optimizer, and based on that, how the results are published and how to analyze those results. Now, taking it forward from that point where we left, today we will primarily focus on first with deployment planning, followed by transport load builder. For the purpose of this demo, I have already taken a optimizer based run so that the demand supply matching is already done at this point of time, and in the network we have already created planned orders, component requirement, as well as stock requisitions. Now, for deployment, the deployment functionality in IBP works pretty much the same as it is in APO. It doesn't create any additional supply requirement, but whatever supply elements that we choose, based on that, it tries to satisfy those demands based on different rules, priorities, and costs. So, if you look into my screen, what I am showing you is the T-lane view in IBP, wherein we have a product 87 which is manufactured in the location YD01, and from YD01 it moves to the destination or the target location YD02, where it is used as a component for the production of multiple finished and semi-finished goods. Now, once I have done with my optimizer, the next thing that I need to do as a part of the deployment is to define the ATD profiles. And ATD profile is something that we can define in the app under the section order based planning, where we have called the available to deploy profile. So I have primarily used the same SAP default ATD profile, wherein for the purpose of this demo, if you see, I have only disabled stock because this IBP system is not integrated with any execution S4 HANA. But apart from that, I have primarily selected STOs, production order, planned order, both fixed and unfixed, purchase requisitions, etc. for my ATD category, so that whatever production plan or whatever stock transfer requisitions have been created by the system, those are considered as a part of the supply element, and based on that, the deployment optimizer will try to satisfy the demands. So this ATD profile is something that we need to input when we give or when we execute the deployment run from the application jobs. Now, before I take a deployment run, I would like to show you how the run is being done or what the numbers look like after the first optimizer has taken place. So for this, I have already loaded the projected stock app, wherein if you see that I have just loaded the product 87 that exists between the source and destination YD01 and 2, and post the run, the optimizer run, you can see that the system has generated planned orders, stock transport requisitions, as well as other supply elements. At this point of time, at this point of time, the deployment has not run yet. So the entire objective is to show you that based on the optimizer, I have my STRs generated. And we can see this STR in the planning view or in the data view as well, wherein if you see based on the optimizer run, the distribution demand has been generated, followed by the distribution receipt. And if you see, there is a lead time of 2 days, hence the receipt is offsetted by the lead time as well. Now, time to run the deployment. So for running the deployment, I will go to the application job template wherein I will run the deployment, which I have already created. So if you see, I have already created two application templates, one for deployment heuristics and optimizer. Since this entire series is based on optimizer, hence I will run the deployment optimizer in this case. So if you look into this selection profile, the primary thing worth not notifying is while running a deployment, we have the option to choose whether we want to run the deployment heuristics or optimizer. We have the option to select predefined filters, and at the same time we need to define the planning run profile as well as the ATD profile that I just showed you before. So for deployment, without a planning run profile or without a ATD profile, we cannot run a deployment. Now I will schedule it. And here we can see that the deployment optimizer has started. Now, we at the same time, we will also take a look into the logs and the results that is being generated by the deployment. So if you see here, the results have been already published and it is writing back the result to IBP, wherein it shows us the cost, and in the planning run profile, in the settings, I have defined that the cost should be generated by the optimizer. So deployment cost generation by the system has been enabled. And based on that, you can see what is the overall solving time, if any technical gap is there, number of constraint. Since it's optimizer, there is no question of pegging, so pegging is ignored as well. And if you see here, the system has taken 103 unfixed stock transfer requisition. Those are nothing but this stock transfer requisitions that I was talking about, which is an output of the optimizer. Based on that, it has primarily created this unfixed STRs are now being converted or has been converted into deployment requisitions. And along with that, it shows us how many demand in terms of forecast or dependent demand are being considered, if there is any getting factor involved, how many supply usage are there, so on and so forth. And now I am done with the execution of the deployment. Now, once the deployment is done, now take a look at how the numbers are generated. At this point of time, if you see in the distribution, demand, receipt, and lane, we have got the numbers that got updated as a result of the optimizer. Now, I will refresh it. After the deployment run, if you see here that now the stock transfer requisitions have been converted into deployment requisition, and hence they are appearing here in this key figure called distribution, demand, lane deployment. And similarly, the same is being appearing in the distribution, receipt, lane deployment, and obviously with the predefined offset. So The sequence is when we run optimizer or heuristics, we generate STRs. Based on what I define in the ATD profile, deployment takes those as available supply element. And in this case, it has considered the STRs as the supply element and then converted them to deployment requisition, which is now being displayed here along with the lead time offset of 2 days. If we go to the projected stock app now and click on to refresh, now you see earlier all the stock transfer requisitions or the STRs that were created are now converted into deployment requisitions. So the job of the deployment optimizer or heuristic is to take into account my stock, STRs, fixed or unfixed based on my choice. And based on that, it will try to satisfy the demands and convert each of those supply elements, for example, the STRs, into deployment purchase requisitions. And this is a source target based run. So once it updates in the source, the same also gets updated in the target location as well, wherein if you see these are deployment requisitions at the recipient at the location YD02. And that's how the deployment is now completed, and I have got my deployment orders or deployment requisitions based on the ATD profiles. From here also we have an option from this projected stock app. We can basically confirm certain deployment requisition to be fixed, or even we have the option to create additional STR and fix them. But those are something that we will cover at a later point of time, because from here you can create STRs, deployment requisitions, and from here itself you can start taking a planning run. So that's how flexible the system is at this point of time. Now with this done, the next step that comes in is TLB, or the much talked or much hyped application transport load builder in OBP. Now for the TLB, we have some additional master data requirement and some prerequisites that we need to follow in order to ensure that we are having a correct TLB run with correct input and giving us a correct output as per we desire. So before taking a TLB run, I will walk you through the master data requirements, and this part is very crucial because the master data structure and the master data requirement here for TLB are a bit stringent at this point of time. But with the flexible master data, it is really easy for us to maintain most of the TLB specific master data directly in IBP. So for that, I will open the TLB specific master data sheet that I have created. So if you see here, first, what I have done is I have created a transportation resource. So in this resource master, if you see, I have created a resource ID called truck 407, where I have maintained it as a resource type 3, which primarily means transportation resource, and I have maintained its capacity in pallets. Then the most important thing that we need to maintain first is called the transportation group. Transportation group is a new master data that is very, very specific to TLB, because the TLB primarily runs based on a transportation group. And what is a transportation group? Transportation group is primarily a aggregator which aggregates based on the group ID. It aggregates the number of distribution loads, distribution receipt, or the product location combination between a predefined source, target, and mode of transport. So once we define this transportation group, We can then go to the transportation lane, wherein I basically define the source and target with the mode of transport, the product ID, and one also additional field called transportation lane ID, which we can create directly from IBP. Along with that, although not roots but mandatory attribute are stock transfer type. For a particular transportation lane to be included for TLB run, the stock transfer type has to be 7 so that it becomes TLB enabled or TLB compatible, along with a valid from and valid to date, which is common, and even we have seen that in APO. Once I have defined this transportation lane here, and I have defined a lead time, one more important thing to understand is for transportation lane to be considered and for TLB to give us a correct run, apart from these combinations, we need to ensure that we have a purchase organization assigned to a transportation lane, and the transportation group that I have shown you just now, we have to assign the right transportation group to the transportation lane. If any of these combinations are missing, that transportation lane won't be considered as a part of the TLB run. And then there are multiple other non-mandatory fields like max, mean, transportation lot size, rounding value, so on, which we can use later, and you know how they works. Now at this point of time, I have created the group. I have created a T lane, assigned the required inputs in terms of transportation group, stock transfer type, purchase requisition, source target, mode of transport, and transportation ID. Now the next part is, I will move on, is called the transportation lane resource. This is where primarily I tag a resource to the transportation lane. Because in order for a good to move from a source to destination, it has to use a transport, or it has to use a resource, a transportation resource. So that's where in this master data, I primarily assign the resource ID to the transportation lane. And then I give a capacity consumption rate, a base capacity quantity, so on. So this is where, if you now look into the picture, is we are creating a transportation lane. We are assigning a transportation group to a transportation lane. And here in this master data, we are also assigning a resource to a particular transportation lane. Then one more type of master data that is also used in TLB is called equipments or equipment types. Now, these are also mandatory master data. Now, what are those? That I will explain. So if you see here in the equipment type, I have created two equipment type or two truck. One is called a big truck and a small truck with a description. Small truck is a 5 pallet truck, big truck is a 10 pallet truck, and so on. After we define a equipment type, we have to specify the equipment type limit. So here, if you see, similar to the resource that I have created, I am primarily assigning a unit of measure or UOM to this equipment ID. And in this case also, I have selected pallets. And small truck means 5 pallets, big truck means 10 pallets. Once I have created the equipment, I have specified upper limit for it. Now I need to map this equipment to the transportation group so that through this transportation group, they get interlinked or linked to the transportation lane as well as to the transportation resource. For that, we use the master data called transportation group equipment. Here, similar to the transportation lane, we define the equipment ID. We give additional key, which by default is 1. And here, if you see, we are assigning the transportation group ID to this equipment. And based on this, also I am updating the validity, the from and to range. And since I'll be using a deployment optimizer, hence I am putting some fixed cost for those individual equipments. So just to wrap up on the master data part, we create transportation group, we create transportation lane, we create transportation resource, then we assign the transportation group to the lane, and we also assign the transportation lane with an appropriate transportation resource. And parallelly, we create equipment limits, which are also kind of a resource max capacity, and then assign the transportation group or the same transportation group to the equipment types. Now, the question might come, why do we have a transportation resource and also an equipment type? The reason behind that is, if you try to recollect it with your those who are coming from an APO background, in TLB we used to have TLB profiles wherein we define truck sizes with an upper limit, lower limit. So those trucks and truck sizes are the equivalent of your equipment type. But in APO TLB, we didn't have the functionality wherein we could have defined those trucks as capacity, put available capacity in them, and have capacity consumption even for transportation resource. That's that is what has been provided in IBP order-based planning, wherein not only we define this equipment, we can also use transportation resource, provide available transportation resource capacity, and then tag it to the transportation lane. So in a way, if you are defining big truck equipment type, small truck equipment type, you can also at the same time create a replica of the same as a resource, transportation resource, big truck, small truck, and assign capacities to them so that not only the load is optimized, but also the overall of capacity of the truck as a constraint is taken into account. So that's the beauty of this tool here. Now, with that done, I am done with the master data setup for TLB. Now it's time to take a TLB run. So for that, let me go to the application jobs, wherein I will primarily create a TLB run from the application job itself. So previously I have run one, so I'll be lazy and copy this one. So this is the TLB input screen where we have to define the planning area, the version, the time zone, which is also very important. Remember one thing, that the time zone that we specify here should be the same time zone as we have maintained in the location master of the source location. So if you see, I have maintained here UTC, and if I go to the master data called location ID for the source location YD01, my location time zone is UTC. So this two has to match. And here I define the number of days for which I'm going to run the TLB. Now, one more thing very, very important for us to understand is the transportation load builder or the TLB doesn't run without a planning filter. And how you create a TLB compatible planning filter is very important to understand, because we can't just give product or location product combination, nothing like that. So I will go to my planning filter. In the planning filter, if you see, I have created a filter called TLB group. And if you see in the planning filter, the criteria for my filter are source location, target location, mode of transport, and transportation group. Here, one thing very, very important to remember is we need to use mandatorily source location, target location, and mode of transport, so that based on these three combinations, the TLB is able to identify the list of transportation group that belong to this combination. Unless and until transportation group is able to be determined or derived by the TLB, the job is not going to run, it will fail. And one thing that you have to make sure in the very beginning, when you are configuring a system for order-based planning, if you are copying it from SAP 7F, that is absolutely fine. But in the settings here, we have an option called planning level for transportation group filtering. So here we have to select a planning level where we have the attribute transportation group ID. If we don't select that, TLB won't run. In this case, by default, I have used the default one called day T lane, because this transportation lane planning level has a planning group associated with it. During an implementation, it could be a different level, a customized planning level, but we have to make sure that we have the transportation group in it. Now, with this done, now I come here, select the appropriate planning filter, and in the receive scope, I have the option to consider the kind of STRs that I want. I could just say that I want to run the TLB based on the deployment requisitions, or I could run the TLB based on all requisitions that include deployment and STRs as well. In this video, for the purpose of demo, we will just select deployment requisitions because we have run the deployment optimizer before. And the runtime, since this is a demo, I have just kept it 1200, but if you leave it blank, a max lead time of 5000 seconds is considered by the system. And here we have support parameter, which we can use down in the future to provide additional parameters that we need for customized solutions. And those parameters can be and would be provided by SAP themselves. With this done, now it's time to kick off the TLB. Now we have scheduled the TLB run, and let's see the result of the TLB. Now, if you see that the job has finished, the TLB run has finished, let's go and take a look into the log, see how it is generated. So based on the filter that we have given, I have only considered deployments requisition, hence the receipt ID is considered. Maximum runtime is 1200. Based on the filter, the system has identified one valid transportation group and the job runs. And the output of the job is it has created 104 load requisition, that is TLB confirmed orders, and 11 STRs have been created or updated, I would say. And if you see here, it shows resource capacity consumption updated. So it is because of the transportation resource that we have created, the consumption is also getting updated here. Now, before I go and take you to the TLB results and show you the TLB results, if you come to the capacity view now, you see that we have the transportation resource called truck small created, wherein I had given some capacity in terms of pallets of 300 pallets of available capacity, and the system has utilized 100 pallets from the available capacity, and hence my capacity utilization or capacity consumption is also getting updated accordingly. Now let's see how the results look. So for this, I will first go to the projected stock again, and here I will click and update to see what all orders numbers are created. So if you see, the deployment requisitions has all been selected as relevant for planning as yes. So that means TLB has selected them and confirmed them as valid supply elements. Now, let us take a look into the TLB results. And the best way to view the TLB result is the planner's workspace. So in the planner workspace, now we have this additional button called TLB. And once you basically load that, select that option, create, give the appropriate version and the filter with the date range, the system will show you the TLB results. So if you see here, we can see based on the time horizon that I have given, there are 72 loads. And if you see, the loads are either fully loaded, and in some cases you can also see partial loaded. So if you see here, this one of this load is partially loaded up to 85%. Then we have something partial loaded of 30%, and there are many that are fully loaded. So if you take any of these loads here, from here you can see the STO item numbers, the product, quantity, pallet size, which primarily tells me that this is the big truck load has been optimized with a start date, end date, which considers your transportation lead time, the source, destination, mode of transport, and what kind of order type it is. It is called the load transport requisitions, along with the T lengths and all. So here you can take a look into different types of loads that the system has created. And at the same time, now if we come to the planning view and I hit refresh, now you see post the TLB run, the TLB confirmed orders or TLB confirmed loads are now appearing in the distribution demand lane load, and correspondingly we can also see the distribution receipt lane load also getting updated. And here with this also the same lead time is being respected in each and every cases. So that means the way the entire flow happens is based on a heuristic or optimizer run, we generate the distribution demands. Based on the distribution demands and whatever we select in our ATD, this STRs get converted into deployment requisitions and appear in the distribution demand lane deployment. Then when we take the TLB run, wherein our input we have selected is just deployment requisitions, the TLB create loads based on the deployment requisitions that are available in the system and converts them into TLB based orders, which appears in the distribution demand lane load or the distribution receipt lane load at whatever location you are seeing. So that's how primarily the deployment and TLB works in order-based planning, which I would say indefinitely is one of the best solution that we have, because TLB we were missing for quite some time in order-based planning, and that was one of the reason why we couldn't have compared it with APO till date. But now with this TLB functionality in built in place, and with future enhancements coming in on top of the existing functionality, we can now say that we have a good parallel solution to the famous APO that we have used for a very, very long time. So with this calls the end of the series of order-based planning with flexible master data. I hope you all have enjoyed this entire series and you have liked it. Thank you. Please do like and subscribe if you feel positive, and if you think there is a good takeaway from this demo. Thanks a lot.